Welcome back everyone again to my channel Chemistry Made Simple for NEET, and this is Dr. Radha Subramaniam with you, and today we are going to continue with a solid state. So already I have uploaded the first part. Today we will be learning the second part, and before moving on with the concepts for today, let me answer a few questions regarding the correction window for NEET asked by many students. So the first question is which fields can be edited in the correction window? So NTA provides the correction window facility only once the application form filling ends or concludes, and only some fields could be rectified in NEET 2021 like NEET 2021, 2022 also, like birthplace, question paper medium, choice of NEET exam cities, address, academic details, parents name, and details on NEET 2022 correction facility will be soon updated. Okay, and what is the class? Can class 12 qualifying code be edited in the NEET application form? Yes, the qualifying code can be edited and you have to use the same login credential to do that. And another student asked me, can I change or update my photograph through the correction window? The answer is the candidates who have uploaded a blurry image will be informed through mail to upload a clear image as per the specifications laid down by the NTA, and the images must be uploaded within the specified time period, and login credentials are enough to upload a passport size photo. Okay, the next question is, will my application be rejected if I upload an image with no name and a white background? And for that the officials have set a notice, or they have given a notice that photos without a name, date or white background will not be rejected, but one must ensure to follow the specifications provided for uploading photographs beforehand to avoid any problems. Okay, next question is, in the application form can you change the address? Yes, the address can be edited through the NEET correction window facility, and you have to use your login credentials properly to do this. Okay, another question is, in the already submitted form you can you change the language preference? No, the option of language once submitted cannot be changed because the allotment of centers is carried out on the basis of medium of the question paper. Okay, hope it is clear for you. These were a few doubts asked by a few students. Okay, now hope it is clear for you, and now you can continue with the remaining part of the solid state, and we will first start with crystal lattices and unit cells. Okay. Just you can see the diagrammatic representation here. The main characteristics of crystalline solids, it's a regular and repeating pattern of constituent particles. Yesterday we had seen that in the diagrammatic representation, and if the three-dimensional arrangement of the particle, that is in a crystal which is shown diagrammatically, each particle you can see can be depicted as a point. Okay, and the arrangement of such see here what is given here, this is called a structure. This structure is called a crystal lattice. Okay, and a regular three-dimensional arrangement of points in space is what we call a crystal lattice. So what are the conditions? It is a three-dimensional and regular arrangement of points in space, and only 14 possible three-dimensional lattices are there. That is what we call Bravais lattices. Okay, hope it's clear to you. Next, see here you can see graphite, and you know both diamond and graphite are different, two different allotropes of the same element carbon, and for graphite it has layered structure like this, and these layers are held by van der Waals force, and the distance between two layers is 340 pm, and each layer is made of planar hexagonal shape, 6 sides. Okay, rings of carbon atoms, and CC bond length here it's 141.5. remember the values for here because maybe it can come for your exam. Okay, each carbon atom in hexagonal ring, it undergoes sp2 hybridization, and it makes 3 sigma bonds with 3 neighboring carbon atoms, and the 4th electron forms a pi bond. So this is why graphite is slippery, and so that electrons can move about conducting electricity. So this is all we have got to know about graphite structure and properties. Okay, now about diamond. Diamond is a crystalline lattice, and what about diamond? Each carbon atom has sp3 hybridization. It's linked to 4 other carbon atoms by using hybridized orbitals in tetrahedral fashion, you can see here, and the CC bond between two carbon atom, the bond length is 154. This is the structure of the diamond. Okay. Now, covalent or network solids, see, you can see diamond, graphite and silica given here. So many crystalline solids of non-metals, they form covalent bonds between adjacent atoms throughout the crystal, and these are also called giant molecules because so many molecules are included in this. And covalent bonds, you know, they are very strong and it's directional, so atoms are held strongly, and breaking of a covalent bond is very difficult, and so therefore they have got high melting points and even decompose before melting. So these are insulators, and so they do not conduct electricity. Fine. Okay. Now next, see crystalline quartz SiO2, see the regular arrangement, and this is amorphous irregular arrangement, that is SiO2. See SiO2, the same SiO2, one is crystalline form and another one is amorphous. Crystalline is quartz and amorphous is glass. So remember the differentiation here. Now what are metallic solids? Now, metals are collection of positive ions surrounded by and held together by free electrons, and these electrons would be mobile and they spread evenly throughout the crystal, and each metal atoms it donates one or more electrons towards these mobile electrons, and the free and mobile electrons are causing the high electrical and thermal conductivity of metals. So if you apply an electric field, the electrons will flow through the network of positive ions. And also when you heat one portion of a metal, the thermal energy is uniformly spread throughout the metal by free electrons. And another important characteristic of metal is their luster and color in certain cases because of the presence of free electrons in them. Metals are highly malleable and ductile. You know, malleability and ductility can be beaten into thin sheets and drawn into thin wires. Okay. Now see here the structure NaCl. Na, it's shown as green color, and chloride minus ion, it's shown in blue colors. So sodium chloride structure is given here, and ionic solids. So ionic solids are made of ions. So these solids are formed by 3D arrangements of cations and anions. It is held by strong coulombic or electrostatic forces. These solids are very hard and brittle and high boiling and melting points. So they cannot, these ions are not free to move about, and they are electrical insulators in the solid state. What is meant by insulators? They do not conduct electricity. But in molten state, when you melt them or dissolve them in water, these ions will be free to move about, and so they conduct electricity. Okay, you know, now this is very important concept, BCC, body centered cubic cell. So what it has each of the corner it has got atom. So 8 corners are there, see, that means 8 corners into 1 by 8 per corner atom. So that will be 8 into 1 by 8, which is 1 atom, and next is 1 body center. See, corners also they are there, and body center also 1 atom. So 1 into 1, 1. So total number of atoms per unit cell of BCC, you say it in short form BCC, body centered cubic, that is 1 plus 1, 2 atoms are there. Remember this calculation. So with that we are coming to an end of this part 2 session, and we will be uploading continuously the remaining part of this lesson, which is very important with a NEET point of view. Many questions you are likely to get for your exam, and always, as I say, do like, share and subscribe to my channel, and support this channel, because it's coming absolutely, the contents are posted absolutely free for you, and we are not planning to charge any fees or any amount for this channel. I feel it would be really helpful for you, because many students have given me feedback that they are finding this really useful, and I am extremely happy to hear this, because that is what is our aim or objective, and I expect you all to support us continuously in this venture. And thanks for watching this video. I will be coming up soon with the next video. Thanks for watching.